Linear combinations and transformations of random variables is a combination of a review of concepts we did previously and something along the lines of what we were doing with probability. So, remind and review. In Chapter 4, we studied the effects of transformations on the shape, center, and spread of a dataset. If you do not remember what I am talking about, then here's a review. Adding or subtracting a constant, let's define that constant as A, to each observation does the following. It adds that A constant to the measures of the center. So, if I have an average test score of 85 for a class and I give everyone 5 points, then the mean moves over 5 points. But it does not change the shape or the measures of spread, so the standard deviation, range, and so forth will remain the same. Multiplying or dividing each observation by a constant, let's call that constant b to each observation. It multiplies or divides the measures of center by the absolute value of b, and it also multiplies or divides the measure of spread by b. It also does not change the shape of the distribution. So if I was to double everyone's score, then both the mean and the standard deviation, let's say it was 2. So this is the mean, this is the standard deviation. If I was to multiply it by 2, then it would double to 170. And the standard deviation would also double. So, linear transformations on random variables follow the same exact rules. Multiplying or dividing each value of a random variable by a constant, again we're calling it b. It multiplies the center by b and the spread by the absolute value of b. Also keep in mind, a random variable by a constant b multiplies the variance by b squared because variance is standard deviation squared. That's actually going to be very important to know. So let's go through this example. Pete's Jeep Tours offers a popular half-day trip in a tourist area. There must be at least 2 passengers for the trip to run, and the vehicle will hold up to 6 passengers. Define x as the number of passengers on a randomly selected day. So this is a discrete random variable because it's on isolated points. It's 2 passengers or 3 or 4 or 5 and so forth. So here's a probability distribution table. If we were to find the mean and standard deviation, then out would come 3.75 and the standard deviation would be 1.09. So let's transform this variable to price. Pete charges $150 per passenger. So how can we apply that to this probability distribution table? Well, we can multiply the each value by 150. If we were to multiply each value by 150, then the mean would change by the multiple of 150 and the standard deviation would change as well. So you notice that by multiplying by $150, each value by $150, it changed the mean and the standard deviation by $150. But let's keep going here. So we've defined the mean and standard deviation once he charges. But it costs Pete $100 per trip to buy permits and gas and a ferry pass. The random variable V describes the profit Pete makes on a random selected day. So what happens when he has to subtract $100 from whatever he ends up doing? So if he drives 2 people, he's subtracting 100. It's now 200. 3 people, he's still subtracting 100. He's consistently subtracting $100. Well, the mean changed by $100, but the standard deviation stayed the same because it only shifted. There wasn't much of a transformation there. So this is an example of how with random variables you add only to the center, to the mean, but you multiply both mean and standard deviation. So there are some rules to combining random variables as well. So the combination means that you want to add 2 averages together or add 2 standard deviations together. So again, adding or subtracting means and standard deviations. This is when we want to combine, linear combination. So the rule is very simple. If you're just adding a constant, then you add that constant to the mean. So it is the mean plus the constant. If you're multiplying, then you multiply the mean by that constant. For standard deviation, it stays the same, excuse me, for variance. But if you're multiplying, then you multiply the variance by that constant. Now, if you want to add two data sets that have two different means together, say you want to add your SAT scores or the average SAT score at Millbrook School or at the college of your choice, or you wanted to add your combined running and biking time for a, a double run, then you can just add those values together and that will give you the total mean. Actually pretty simple, right? And likewise, if you want to subtract, then you would subtract those two values from each other. Okay? So it follows the basic rules of arithmetic. But this is not the case with standard deviation. You can never combine standard deviation because it is a distance formula. It talks about a distance. So think about a right triangle. When I want to find the hypotenuse, I don't just add the two legs together. What I have to do is find the variances. So find the variance of your math SAT score and the variance of your verbal SAT score and add those together. And then, whatever my answer is, I take the square root. I'm going to repeat that. You add the variances together, or you square the standard deviations first and then add them together. So add variances, never standard deviations. And then you take the square root of the combined answer, and that is your standard deviation combined. So that's rule number one with standard deviation. Rule number two is actually pretty simple. You never subtract standard deviations. Even if the problem says something along the lines of subtraction, you don't subtract standard deviations. When it's asking you to subtract, you still combine them as if you're adding. Because standard deviation talks about the distance. If you combine two things by subtracting, to talk about their distance, you have to add them together. So these are important concepts that you will need to practice, but never ever combine standard deviation and never ever subtract standard deviation or variance for that matter. Okay? You only, 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 only add. Okay? So take a minute to pause or rewind if you were not able to follow along with that and just re-watch this component of the video. When you do problems, it's really straightforward. I'm actually going to do a couple examples with you now. So suppose the average SAT math score is 625 and the standard deviation of an SAT math score is 90. The average SAT verbal score is 590 and the standard deviation is 100. The composite SAT score is determined by adding the math and verbal portions together. So what is the mean standard deviation of the composite score? Well, the say the x variable is math, y is verbal. So we just add the means together. 625 plus 590. So the total score is 1215. But what about the standard deviation? Well, again, We don't add standard deviations. We add variances first. So we have to square 90 and square 100 and then take the square root of that. So 90 squared plus 100 squared and then take the square root of that is approximately 134.54. So the standard deviation of the composite score is 134.5. So we have two golfers here. Mr. Molsky scores average 110 with a standard deviation of 10. Mr. Liberty scores averages 100 with a standard deviation of 8. Find the standard deviation of the differences. So assume that they're normally distributed, which means that they're independent. So again, we can just subtract the differences. So their difference is 10. But to find their standard deviation for this distribution, we still have to add the variances. Okay, because we're talking about the distance between the two. Okay, so 10 squared plus 8 squared. You take the square root of that. And out comes approximately 12.8. So in the difference is 10 for the means, but the standard deviation combination is 12.8. That's all I have for you today.